My name is Lara Newsom. I am a software engineering technical leader on the customer experience team at Cisco. I am also a co-host on the Angular Plus show. You'll be shocked to hear this is a podcast where we talk about Angular quite a bit. You can also subscribe to that anywhere that you get your podcasts. We have a lot of great guests on. In fact, Maria's episode was just released this week. So if you'd like to talk about coffee and dependency injection with Angular, the Angular Plus show team and Maria and I, please check that out. I can also be reached on Twitter at Lara Newsom. Again, the topic of my talk is called Stop Micromanaging Your State and Start Being Reactive. I do have a link to my slide deck here. I do have some code examples that are a little bit small, so you may follow along if you'd like. I do have also some links at the end to further your knowledge, because it turns out being reactive is a very large topic. I also wanted to point out, first of all, we're entering a shame-free zone. If you see code on the screen that looks like code you're writing, it's okay. There is literally code on the screen that I think I wrote. So I'm not here to make you feel bad about your code. I'm not here to tell anyone they're bad at their job. I'm here to point out some patterns that I have seen that have made my job harder and talk about ways to make your job easier. I also just want to take a moment to thank the organizers of this conference. As they said in the beginning, it's a lot of work to put this together. I also want to recognize the speakers. We pour a lot of love and time into our talks. I'm a very nervous person. What you can't tell is right now my hands are sweaty because I'm very anxious to be here on stage. But I'm also very approachable. So I think I could speak for all of the speakers. You're welcome to come up to us afterwards. Tell us what you like about the talk. Ask us questions. Say thank you. We all appreciate any time that you give us, and because we try to give you as much of our time as we can. So. So to get started, let's talk about what this state micromanagement is. I'm calling it an anti-pattern, and sort of a dictionary-type definition would be when state is imperatively declared and managed inside a component. But the symptoms of this are brittle and difficult to understand code. So if you have a component where when you get a bug ticket filed on it, you're not really sure if fixing the bug is just going to introduce a new bug. Those are the components I'm talking about. It's components that are not easily scalable or shareable. So if somebody says, hey, we want to develop a new feature on this component, and your heart kind of starts beating fast and you know it's going to really suck to do that, yeah, those are the components we're talking about. It's those extra large components, not like the 200-line components, but like the 3,000-line components. Those are the ones we're talking about, right? So how do we get into this pattern of imperatively programming? Well, unfortunately, for a lot of us, that's how we were taught to code, right? We were trained to code imperatively. And in fact, in the Angular Tour of Heroes, the example is that it is that pattern, right? Where you're setting a component property, you're directly subscribing to services inside your component, and then setting those component values. Now, there's nothing wrong with this code. It does work until it doesn't, right? Because if you keep following this pattern, it can start to get out of control. So let's take a little closer look at this state micromanagement anti-pattern. So some of the code patterns that I'll see with this micromanagement anti-pattern are redundant or unnecessary component properties. So how many of you have components with over like 20 component properties? You know, like there's a lot. Yeah, same. I have a lot of these. They're my good friends. I work on them every day, right? And then you have void methods that are mutating state. Right? So these void methods often take nothing in, they return nothing, they just mutate a bunch of stuff inside of them, and you have to follow through a long chain of these these methods. And then there's a lot of direct subscriptions inside those components. So the problem number one, imperatively declaring all state and component properties. So let's meet some of these properties. There's certain types that we see, right? first we have our derived state properties. These are you see a lot of counts, a lot of like Booleans to be like, is it loading? Is it an error state, right? These are all properties that we can find other ways, right? So here's our count property. Here's an example of a count where every time I add a new cat to this, to my cats array, I have to increment the count on the cat count. And if I forget, it doesn't increment, and then I have to figure out why, right? So the problem with derived state is it's disconnected from the source. You've actually set up a problem where you have to manually manage those properties. It's prone to error or prone to bugs because I'm just a human. I might not remember that I have 15 count properties I need to manage every time something happens in my app. Another flavor of component property we see are arrays to track changes. So here we have selected IDs and selected IDs edit. I assume one of those is editing something, but I'm not really sure because I also have add IDs, deleted IDs, exclude IDs, new edit or edit new IDs. I'm really surprised we don't have selected IDs new or old selected IDs, right? Like, because these are the types of properties we see in this pattern. And then if you look at how they're set, you go through and, oh, look, it's just a copy of a copy, right? And sometimes you'll find a copy of a copy of a copy. Sometimes you'll get Lodash in there doing a deep clone of the array, right? So why do people do this? Well, because we're doing a manual process, right? We're trying, it's an issue because it is a manual process. It becomes very quickly tedious to try to remember what each of these properties is supposed to be doing. And again, I'm just a human. I only have so much room in my head to remember what selected IDs versus what selected IDs edit, what selected IDs edit new is for, right? So why do people do it? It's to maintain previous state, right? We're basically copying our code so that we can mutate it, because in the end, we don't want to have to go get it again by making another data request. Another brand that we end up seeing are redundant properties with confusing names. This is one of my favorites. I found this in the wild. We've got is all selected and is select all. What is the difference? I still haven't figured that out, right? So how do we end up with so many different properties? Well, we're trying to respond to different events, right? Like, we're trying to manage, like, should the modal be showing? Are we in error state? Should we be loading? Like, what's happening in our app? It's very manual. And I also feel like there's I call it property fatigue. So when you open one of these 3,000 line components and you're like, what does this select all? What is this for? I can't tell. I'm just going to make a new property, right? So you end up making new properties because you can't figure out what the old properties are doing, but then you're still afraid to delete that other property because I'm not actually sure what it's doing, and I think if I delete it, I might break the code. So you end up with a lot of dead code or repetitive code that just doesn't need to be there. So problem number 2, we've got our void methods that manage the state of all of the many component properties, because when you declare all of your state in component properties, you got to change that state somehow. And so we tend to do that in void methods, right? So this is, again, a very manual process of mutating these component properties that becomes quickly tedious. You're going to notice a pattern here, right? These void methods are very tightly coupled to your component, right? Because they don't take anything in, and they don't put anything out. They simply mutate component properties inside of them. So why do people end up using these? Well, it's because we have stateful properties, right? We have to manage that state somehow. We have to react to events. And frankly, it's kind of fast and dirty. It's easy to do it that way, right? I don't have to think very hard. I'm just like, oh, yeah, I got to add this to this array. I got to change this flag here. But do you ever wonder how we end up with 3,000 line components? I'm going to introduce you to my friend select all. I found this in a component. This is 40 lines in one method, and all it's supposed to do is select all. So we can see our friend, you can't really see it here, but if I were to zoom in, you would see that we are not only toggling is select all, we're also toggling is all selected, but I can't tell the difference, right? And then we're setting a bunch of our arrays back to empty arrays. We're pushing to them. We're splicing them. We're for-eaching over them. We're doing all this work. And if you ask me to change this method, it's going to take me a while to figure out what it's going to do. I might just rewrite it, right? Because I don't know. So let's look at another method we might want to reuse in another component. So here we have a method that's called validate product group name, right? So we can see that it's toggling component properties back and forth, right? Another problem I see with this right away, we've got a regex string that's just hard-coded in there, which means I can't share that with any other component in the application. Anytime I need that exact string, I'm going to either be copying it and pasting it or hoping I type it out right. And then, for some reason, at the end, it invokes another method. I don't know what that one does. I'm going to have to go track that down, right? So if I wanted to share this out in another component, I really can't unless I import this component. And that won't do any good because it's mutating component properties, right? So I do some copy pasting, right? I take that code, I copy it, and I put it in another component. And this is how we end up with a code base that's just full of duplicate code. I'm sure there are some of you out here who have components with nearly identical methods in every single component. And if you change any of them, you have to go find all of that duplicated code and hope nobody renamed it, right? Problem number 3, we've got our direct subscriptions and response handling inside of our component. So how does this happen? Well, it turns out when all of your state is managed in component properties, that incoming data has to get surfaced inside your component so that you can set those component property values. So the risk of this is memory leaks. Again, it's a very manual management of state, and you can end up with nested subscriptions, which can introduce race conditions, right? So first, let's talk a little bit about observables versus subscriptions. So observables are lazy. They do not execute until they are subscribed to, whereas subscriptions are the resources that are actually executing the observable, right? So once you subscribe to an observable, that subscription actually exists outside of the context of the component. So open subscriptions are going to continue to execute whether or not your component has destroyed. So if you subscribe in a component and you do not unsubscribe, that subscription will live on forever in the memory of your app. And eventually, that's a memory leak, and eventually you can end up with performance issues from that. So there's several different ways that people have come up with to manage this. I've got the take until pattern here. This is a decent, if you have to subscribe in your component, this is a decent pattern. This will, on component destroy, it will close out the subscriptions created inside this component and unsubscribe them for you. So that sounds great, right? That sounds like our solution. Well, the problem here is that this build table method is actually creating a new subscription every single time it's invoked. So if I invoke this method 7 times and I console log out the service that it's attached to, I'm actually getting 7 different subscriptions. So for long-running components, you can see how this could be a problem. If every time I invoke that build table function or method, let's say I do it every time I sort the table, every time I select something, anytime I've got to rebuild that table, I'm making new subscriptions every single time. And if I'm forgetting to also unsubscribe, it starts to snowball, right? And then we've got our void methods that compound this issue by hiding nested subscriptions. So here's an example of a component method. So first of all, we can see where it's already managing a whole bunch of component properties, making copies of copies, as one does. And then at the very bottom here, it's invoking another method. So inside this subscribe block, we've invoked another method. And if we go to that method, it also has a subscribe block. So this is a nested subscription. Now, the problem with this is that this can introduce a race condition. Every new subscription is a new resource in memory, and every subscription has to be unsubscribed, right? Remember this? Well, instead of doing just 1 subscription every time we invoke that function or that method, we are now creating 2. So it starts to add up on itself. And then we get to the race conditions. So when you nest subscriptions, there's nothing to guarantee that the first subscription is going to return before the second subscription. So if I release, the first value that comes through is my kayak, and then I release my raft, there's nothing to control that kayak from capsizing, from stopping for lunch on the side of the river, right? That raft can overtake that kayak at any point, And then when the kayak comes in, it's going to overwrite the values that we thought we were going to have from the raft. So you end up with mismatched values in your component. And these bugs don't happen very often, but when they do, it's really confusing to track it down, right? So let's see how this pattern can devolve into code chaos. So we're going to follow one method through this component. We've got our getSelectedProducts for edit, and we're going to invoke that in our ngOnInit. So we've seen this one before. It's got a whole bunch of component properties, and then at the end, it goes and invokes another method, right? Which, again, has the nested subscription inside. So who likes race conditions? But it also is, now it's invoking, when the subscribe comes in, it's invoking our handle results. So who wants to guess how many lines of code are in handle results? Did anyone guess 65? So there are 65 lines of code in this, and it's all manual management of properties, right? So I challenge anyone to walk into this component and figure out exactly what's happening. And that's just one flow through the component. That entire component specifically was 1,500 lines of code. That's a lot of code to have to wade through anytime you need to make changes, anytime you need to fix a bug, and it's a lot. So what can we actually do if we're already following this pattern? Well, we can try coding reactively, right? That seems very simple. Simply code reactively, everybody. Everyone's doing it. It's fun. And you sort of end up in this position of, am I going to refactor? Am I going to rewrite? And that's not really an easy decision. There is a pattern where you can fully rewrite a component. I've done this often where I feature flag at the router level. So if the flag is on, we go to the old, or off, we go to the old component. If it's on, we go to the new component. And that's a way to fully rewrite the whole component. Or you can refactor in place. I've also done that. That's a better way to sort of gradually leak out changes. So following some of the advice I have coming up, you can start to make slow improvements to your application by even doing something as simple as no longer using derived state properties, right? If you find yourself referencing the same array length every single time, you don't need that property, right? Get rid of it. Step one, though, for whether you're rewriting or just refactoring, is to understand what your component actually does and what it actually needs, right? Really pare it down, because we don't want our components doing all this work. That's not what they're for. They are for displaying data and recording user input, right? So I've got a very simple component here that we're going to walk through this process with. So this component displays a list of products that can be filtered by type. So what are its data needs? Well, we need products, and we need filter values, and we also need to know how to select a filter, right? But do we actually need products? What we really want are filtered products, because even if there are no filters applied, that products array is still technically filtered, right? No filters is still filters. The problem is if you pull products into your component, the minute you just pull products in, now your component is where you're going to have to manage the state of that, right? So if you pull those products in, you have to, anytime a filter's applied, you have to figure out what to do with that information. Whereas if the component is only getting the filtered products in, all it has to do is display them, right? And then do we really need filters, or are we really more interested in filter selection state, right? Because really all my component is doing is displaying the list of filters and whether or not they're selected. And then we also have the ability to click one, right? So what we actually, and the difference again with the filters and versus filtered selection state is if I pull the filters in, now my component has to manage which ones are selected and what happens when they get selected. Whereas if I'm just pulling in the filter selection state, my component's just like, yeah, I know what to do with this. I'm going to show it on the screen here. So what we really need are filtered products. We need filter selection state, and we need a filter change event, right? Those are really the only things that component needs to do. So step one, we're going to set up some streams. So we'll use observable streams. Why observable streams? Well, subscribed streams continue to execute as long as they stay open. So that means that as new values come into the stream, components can just react to those new values. That's what we want, right? We don't want to have to decide what happens if we click a filter. We want it to already just be sort of happening for us. So how do we get our data into streams? Well, there's a couple different ways we can use service with a subject. We can use a state management library like NGRX. We could use Akita, something that provides the state for you. You can use something more local like NGRX component store. But for the remainder of this talk, we're going to follow service with a subject because everything you need to do that will be built into the Angular library already. You don't need to get permission to pull in a new library. You can just use what's already there. So first, let's talk a little bit about subjects. There's 3 main types of subjects that I typically use for this. There are more types of subjects, but they get a little more niche. So we've got subject, we've got behavior subject, and we've got replay subject. Now, all subjects are hot observables. If you've heard hot and cold observable before, and it kind of makes your head feel fuzzy because you're like, I have no idea what you're talking about. Hot observables are like tuning into a live podcast or a radio station or a TV network, right? It's running before you get there. You subscribe, you get what's there. When you unsubscribe, it continues to go, right? Whereas a cold observable is more like Netflix, where you're like, I want to watch this movie, so it starts when you start, it ends when you end. So subjects are hot observables. So the basic RxJS subject does not have an initial value, and it does not replay values, but it can have multiple subscribers. So when I say it doesn't, initial value, that's pretty straightforward. It just doesn't have an initial value. When I say it does not replay values, that means that if you were using this for something like a token service, and you store it in a subject, and you get the token, and then something subscribes after the token has been retrieved, it won't get that value because it's not going to replay it to it. So a basic subject is better for something like an action, like a click, right? Like where you have, if you're there, if you're subscribed when it happens, then you want to do something about it. If you want to have a cache value, you need to look at something like a behavior subject or a replay subject. A behavior subject does require an initial value, and it will cache the last value. So that would be great for a something where whatever comes in needs to get that value. So if you've got like a selected ID, right? If you set that, you want anything that subscribes after it gets set to also get that value until it changes, right? So it'll cache the last value and again can have multiple subscribers. And then we've got replay subject. So replay subject does not have an initial value, and it will store, it takes in one optional parameter, which is a number, and it is either going to store literally all of the values, so if you don't pass in a parameter, it will replay every single value in that stream to every single subscriber, or what I typically do is I give it number 1, right? Sometimes people will give it number 2, but usually 1 is enough for me, because I just want it to replay that last value. And again, that can have multiple subscribers. So, with that said, we're going to first set up a service for our products because we need to start getting the data for our component. So I'm going to set up a product service. I'm going to declare a singleton service because I want anything that subscribes to this service to get, anything that injects this service to get the same instance of the service. I want them to get the same products, right? I'm also going to use a behavior subject because I do want there to be an initial value, even if that initial value is an empty array. And I'm going to declare this as private. So the reason we're declaring it as private is because only the service should have access to the actual subject. We don't want just anybody to be able to call next on it. We also don't want any component to be able to accidentally complete the stream and ruin it for everybody else, right? It also sort of centralizes our logic into one component or one service. So then we're going to connect the data provider to the actual product. So again, this is still in that product service. We're going to make our request to the API service, and we're going to call this.product. So that's our service.next. And so that's going to push the first value, well, it'll be the second value because we have the behavior subject. It will push the initial products into the stream. And we're going to follow that same pattern for filters. So again, we'll make a filter service. It'll be a singleton service. We're going to use behavior subject because we do want an initial value. And we're again going to declare that as private. So that's the initial state. But that's not what the component needs. So we haven't even made those public yet, right? Nothing can actually access any of the subjects that we've just created. Because we want filtered products. We also want filter selection state, and we want filter change events. So let's set up a filter selection state stream. So this will be in our filter service. And so we're going to create a new subject called selected filter. And it's just going to it's going to be single values, right? Single selection values. It's a behavior subject again, because even if it's undefined, I need there to be an initial value. And I'll explain that in just a second. And then we're actually going to expose a public method on the service to be able to allow our components to call next. So this is how our components can push data into that stream. Right there. And then we're going to provide a public observable of selected filter state. So this is how our components are going to be able to get a list of selected filters. So we'll access our selected filter observable. So we'll use the as observable to expose that. We've got our public selected filters property declared. It's got a $sign on the end that indicates that it's an observable. And then we're going to use the scan operator, because we're getting individual values in, but what we want out is actually an array of the selected filters. So the scan operator works a lot like the reduce method in JavaScript arrays. So it has you declare an accumulator. So in our case, it's an empty array to begin with. And then depending on the state of the incoming filter, we're either going to remove that filter from the selected list or add it to the selected list. And then if we have, and then at the end, so we get single values coming in, but since we're using the scan operator, in the end we're going to get a string array coming out. So now we're going to combine that selected filter state stream with the filter stream. So we have one where it's collecting what's been selected, and then we have one that has the initial, all of the filters inside of it. So we're going to expose on the filter service, we've got our product type filters. And again, we're going to expose this is going to reference the product type filter. That's the initial array of filters that we got from the API service. We're going to use combine latest with. Now, the reason I chose behavior subjects for this is because combine latest with waits for any of the streams inside of it. So it's got the outer observable, which is the product type filters, and then I've passed into it the selected filters, which is that string array. So it's going to wait for both of those streams to emit a value before it will emit any values. And so that's why I want that initial state. And so anytime either of those observables emits a new value into the stream, combine latest will then run it again. So we're going to, it's going to actually, what comes out of combine latest with is an array of, the first one is the outer observable, and then any other observables that you pass into it will be comma this, comma that, comma 1, comma 2. So we've got filters and we've got selected. So once we've combined the streams, we're going to map this. We're going to map the selected values. So I'm going to go ahead and iterate over the filters, and if they are on the selected list, it will set the selected value to true. If they're not, it's going to select it to false. And then if there are no selected filters, it's just going to return the entire filter array, because we want them all to come out. They are initialized as not selected. OK, so now we have our product type filters observable, and we can provide now we can provide the selection state to the component. So this is what the component needs. This is one of our data types that we need. So in the component, we can declare an observable property and create a method to invoke the public API of the filter service. So you can see I've declared a component property, which is an observable, and then I've declared a public method so that I can invoke the public method on the filter service. I'm going to subscribe to that observable property in my component using the async pipe. Async pipe will handle subscribing and unsubscribing for us. It's frankly less component code to write, and it sets up a component for on-push change detection, which is a little outside of the scope of this talk, but it's something to look into. And then on click, we will invoke the change filter selection method, which will then push a new filter value in, which means that our template will automatically, the is selected property will automatically update if it's selected or not. So now we need to merge our filter selection state with the product stream. And good news, I do have this code pushed up to GitHub for you, so you can look at it in its entirety. So in the product service, we're going to expose a public observable called filtered products. Again, we're going to get the observable off of the product subject. We're going to use combine latest again. And we're going to combine that with the selected filters array, which is that array of strings. And so if the property, we're going to map through that. If the property, the product type of the product is included in the selected list, it will get passed through and returned to the component. And then if there is nothing selected, it will return all the products because it would be unfiltered. And then in our component, again, we're going to use the async pipe. We're going to declare a component property, which is an observable. And then we've got this thing running. So let's go check it out in the browser. Let me see, actually, if I can get there real quick. So here is my new and improved. So you can see this still functions as you would expect it to function. But now, if we go back here, hopefully this works correctly. Yay. It's working, and you get the smiley face emoji. Actually, you don't, but if you need one, I'll let you borrow that one. But in the end, our final component is less than 30 lines of code. We've got 2 component properties, and we've got 1 method that knows how to say, hey, something got selected, right? And then we have 2 services that can be shared. So we have a filter service, and we got a product service. So any other component can now access this data as well. And those services are going to be a lot easier to test and a lot easier to refactor. So if you need to change out your API service, it's very easy to do, right? So I understand that there's a lot to learn about reactive programming. There's a lot to learn about state management. Don't feel overwhelmed. You can work in baby steps towards it. The more you can train your brain to think reactively, the better. I also want to point out that you are in the right place to learn more about this. We've got a lot of wonderful speakers here, including my very talented coworker, Alika Krushko, who will be on this stage at 12:15 tomorrow. Yeah. Oh no, he's blushing. And he'll be talking about how to use NGRX component store. So that's another really great option, and he's a really great teacher for that. So don't miss that, I want to say episode because I'm in podcast land. Don't miss that episode. It'll be here on the stage. And then again, as promised, here are my links. So again, this is a huge topic. There's a lot to learn, but there's some really great. And the very top one here, the code example, that's my GitHub repo. And then again, this is the link to the slide deck. So, all right, that's all I have for you. Thank you so much for having me here.
Thank you.